Now we will explain some basics of cost-benefit analysis. However, not in detail, as there is a lot of literature and online courses about that. We will though explain enough for you to perform a number of basic calculations. First of all, every project has costs and revenues. Let's start with the cost. This is a bit of a simplification, but typically we consider two types of cost. The first is the initial costs at the start of the project. You will need to pay an upfront sum of money for initial investments, for instance, to install a PV system or to insulate your house. Next to that, there are annual costs. These costs include, for example, operation and maintenance costs. Also, insurance can play a role. But often there are not only costs but also benefits. Initial upfront costs are also referred to as capital expenditures or CAPEX, whereas annual costs are also referred to as operational expenditures or OPEX. But when we are looking at energy projects, we also often have benefits or revenues. For example, in the case of an energy efficiency project, we save energy costs. In the case of renewable energy projects, we produce electricity or another energy carrier that has a certain value. Next, we are going to discuss cost-benefit analysis. An approach that virtually everyone knows is the simple payback time. In basic terms, it is the number of years it takes to earn a certain investment back and is represented as a fraction of CAPEX over the benefits minus OPEX. So, in the denominator you see here the annual net revenues. We often find a payback time of 2 or 3 or 4 years very attractive for an investment. If it is more than 10 years, careful consideration is required for the project. The simple payback time is used by households, but also often in companies. However, economists do not consider the simple payback time a very good measure for cost-benefit analysis. One of the reasons lies in the fact that the interest rate is not taken into account. There are two measures that are considered better for project evaluation, such as net present value and the internal rate of return. The net present value is the difference between the present value of cash inflows and the present value of cash outflows over a period of time. If the net present value is bigger than 0, then we find it a profitable project, and if it's not bigger than 0, we don't consider it as an attractive project. The internal rate of return is the average return on capital that an investment is expected to generate, or the discount rate for which the net present value is exactly 0. Maybe you are already familiar with these concepts. If not, in the additional material you will find links to courses that introduce you into these. In this course, we will not use these formalized cost-benefit measures, but will take an approach that is largely equivalent. What we will do is to always determine the annual costs of a measure. For the OPEX, that is simple, because the OPEX is already an annual cost element. But for CAPEX, it is different, because if you make an initial investment, you need to consider the fact that you not only need to pay the investment back, but you also need to pay interest. So that's why we calculate the annual cost as the CAPEX times a capital recovery factor. The capital recovery factor can be interpreted as the sum of interest plus depreciation. Now you may wonder, what is the capital recovery factor? It is a measure that depends on two factors: discount rate and depreciation period. Here is a table that you can easily refer to. The exact calculation method is given in the additional material after this video. In this table you can see that as the interest rate grows, so does the capital recovery factor, which is what you would expect. The depreciation period can be taken as the lifetime of the equipment, and you can imagine that the longer the depreciation period, the more time you have to earn the investment back, and the smaller the capital recovery factor. Thus, the capital recovery factor increases with decreasing depreciation period. This is a simple table that you can use in all the further calculations. The table will also be in the additional material for easy referencing. Before we turn to the cost-benefit analysis of climate measures, let me give a simple example of how this approach can be used. We will use it to calculate the levelized cost of energy. The levelized cost of energy is used to calculate the cost of energy taking all cost elements into account. You can, for example, use the approach for various types of electricity production, e.g. from a wind turbine or a natural gas-fired power plant. Here you see the approach. So in the denominator we see the annual costs, and that's first of all the CAPEX multiplied by the capital recovery factor. The OPEX, the annual cost for operation and maintenance, is added to that. The total gives us the annual costs in the denominator. We then divide that by the energy that is produced per year, and then simply we get the cost of electricity per unit of energy, for example, per kilowatt hour. Let's look at an example. Assume you invest in a solar energy system on your roof. Let's assume it's a system of 3 kilowatts and it produces 3,600 kilowatt hours per year. The initial investment is 5,000 euros. The maintenance costs are 50 euros per year. Assume that you can take an extra mortgage on your home to pay for the initial investment and that the discount rate is 4%. The system will last for 25 years, at least. Now we go back to the table and we would see that for this combination of 4% and 25 years, the capital recovery factor will be 6.4%. Now we apply the formula that we were shown on the previous slide for the levelized cost of energy. Once we fill in the numbers, we get 5,000 euros times 6.4% plus 50 euros divided by 3,600 kilowatt hours, resulting in roughly 10 cents per kilowatt hour. So that is the levelized cost of electricity. You can compare the electricity that you produce with the price of electricity that you pay to your utility. And if the price is, for example, 15 cents per kilowatt hour, it would be attractive to invest in the solar photovoltaic system. Having learned about various costs for energy projects, there are some points to keep in mind. The levelized cost of energy is used very often to compare energy sources, but it only gives a first impression of what the cost of electricity will be from a certain source. One must be careful, as it only works if the cost per year is a constant. If you would have a system where you will make an investment with batteries and you would have to replace the batteries once every few years, that calculation would become more complicated. A more important downside of this approach is that it doesn't take into account system cost, especially in the case of wind and solar energy. And if you move to very high penetration rates of these sources, say over 70%, then the cost of system integration can be quite substantial, as we will see later. And these costs should actually be taken into account if you compare with other energy sources. Having said that, the levelized cost of energy is a very useful measure to get an indication of how different energy sources compare in their cost. This approach is just the first application of how you can use annual cost in cost-benefit calculations. In the next video, we will see how we can use the same approach to calculate the cost of greenhouse gas mitigation.